Hello Year 8 and welcome to today's lesson on rounding to decimal places. Please rule off where you got to last lesson and write the title and the date, that'd be fab. So rounding to decimal places today. Have your calculator ready. You're looking for this button, the square root button, which you'll need for doing our task. And please pause the video as you complete this task. Thank you. Right, lovely. Okay, so the answers you should have are 6, 10, 8, 10, 10, 9, 30, 90, 70 and 40. Okay, so just recapping rounding to one significant figure as we did last lesson. Right, lovely. So our success criteria today, so bronze is know how to round decimals to the nearest integer. Remember, integer means whole number. Silver is to understand how to round to one decimal place, and then gold be able to round to 2 decimal places. Okay, so first things first, we'll have a quick look at this hook question and just see if you can maybe do this now. So Paul is performing an experiment with 2 dice. Okay, 2 dice. Paul wants to identify rounding patterns. Paul rolls a 2 and a 3 and he can combine them to make 2.3 or 3.2. When rounding each number to the nearest whole number, one rounds to 2 and the other rounds to 3. So we know that would round to 2 and that would round to 3. Paul repeats this experiment. Could he ever roll the dice and get a pair of numbers that rounds to the same whole number when both values from each dice are combined? Please pause the video and see if you can do this. Right, lovely. Well, let's think about it carefully. You might have said, well, what if he rounds a 1 and a 1? When you combine, you can get 1.1 or 1.1, and they would both round to 1. And that would similarly work with any pairs of numbers that are the same. You're rolling 2 dice, you could get a 5 and a 5, so you can combine them to get 5.5 or reverse the 5s, 5.5. So if you have a pair of the same number, that would get you to round it to the same integer. Lovely. Okay, so round to the nearest whole integer. So we're going to look at the first number to the right of the decimal place, and it's an 8. Is it 5 or more? Well, yes, it is. So we round up to 5. 4.8 becomes 5. Then we've got 4.3. So we're looking at, again, the first number to the right of the decimal point. That's, is it 5 or more? No. And we know the rules of rounding are 5 and you round up and 4 below and you keep the same. So we get 4. Then we've got 8.852. So again, we're looking at the first number to the right of the decimal point, which is the 8. Is it 5 or more? Yes. So the 8.852 becomes 9. Then we've got 24.87. So again, we're looking at this 8 here to the right of the decimal place. Is it greater than 5? Yes, it is. So we actually get 25. So look, we're just round to the nearest whole integer, not the nearest, not the first significant figure or anything like that, just the whole integer. So we have our whole integer there. Then 15.267. So we're going to look at the 2 here to the right of the decimal point. Is it 5 or more? Well, no. So the 15 stays the same. And then we've got 9.967. So we're looking at this 9 here to the right of the decimal place. Is it 5 or more? Yes. So that 9, this 9 here is rounded up to a 10. Lovely. Can you please have a go at these questions here? Please write them down. So for example, for the first one, you might write 3.6 equals and then the answer to the nearest whole integer. Please pause the video as you do this. Fab, so you should have 4 and 4, 13, 16, 7, 4 and 1, 8, 103, because we can see there whole integer, 102 on its own is a whole integer. We're looking at the 5, it's 5 or greater than, so it rounds the 2 up to a 3, 150, 14, 38, 53 and 49. If you've not quite got this right, please go back and have a look at the teacher examples on the previous slide and have another go at these questions. Right, brilliant, rounding to 1 decimal place. So this time we're looking at the second number to the right because this is the value that might change because we want one number for the decimal point, so it's the next one that's in charge. Is the 3 5 or more? Well, no, it isn't, so you get 4.8. Then we've got 4.8425. Is that 4 5 or more? So when you remember, when you round into 1 decimal place, it's the second decimal number that you're looking at that's in charge. It's not greater than, it's not 5 or more, sorry, so you get 4.8 again. Then we've got 4.852. So that is 5 or more, so it rounds this 8 up here, our 1 decimal place, to a 9. We get 4.9. Then we've got 4.87. So we're looking at the 7 here. That's the first decimal point. That's what might change. So does the 7 round it up? Well, it's 5 or more, so it does, and you get 4.9. Then we've got 5.26714. Well, all that's important is our first decimal number, which is a 2, and the 6, because that may change things. Oh, apologies. That may change things. It is 5 or more, so you get 5.3. And then you get 1.967. Well, again, the 9 is our one decimal place, so the 6 is in charge. It is 5 or more, so it rounds it actually to 2, because remember we said the knock-on effect, that 6 rounds that up to a 10, which has a knock-on effect here, so that becomes a 2, okay, and then it's 0.0. Because we're rounding to one decimal place, you have to put the 0.0 in, otherwise you haven't rounded to one decimal place. Right, brilliant. Have a go at these questions here, please. Please pause the video as you do this. Right, lovely. So you should have 3.6, 4.8, 2.8, 5.8, 6.9, 4.1, 9.1, 8.1, 9.0, 3.1, 0.5, 0.1, 0.4 and 0.5. Brilliant. Right, now rounding to 2 decimal places, so our gold criteria here. So we're looking to round to 2 decimal places, so we want 2 numbers to the right of the decimal point, but this is the one that might change, the 3. It could have a knock-on effect here, but it won't in this case, and it's the 2 that's in charge of the change. Is the 2 5 or more? Well, no, it isn't, so it doesn't affect the 3, which means there can be no knock-on effect further down. So we get 4.83. Now we've got 4.846. Well, we've got our 8 and our 4 to the right of the decimal place. Is the 6 5 or more? Well, yes, it is, so it's going to have a knock-on effect here, and change that to a 5, but luckily, because it hasn't changed anything to a 10, it has no other knock-on effect, so you get 4.85. Then we've got 4.85951. So the 9, is it 5 or more? Yes, it is, so it becomes 4.86. And then we've got 1.6949. Well, does that 4 affect the 9? It isn't, because it's less than 5, so it's 1.69. And then we've got 5.267. So we've got our 2 decimal numbers here. 6 is probably the one that's going to change, and the 7's in charge. Is the 7 5 or more? Yes, it is, so it rounds up to 5.27. Then we've got 1.897. Well, that 7 rounds that 9 up to a 10, and we know, therefore, that that's going to have a knock-on effect here. So it becomes 1.90. The 7 rounds the 9 up to a 10, which rounds the 8 up to a 9. Okay, lovely. Right, brilliant. Please have a go at these questions and pause the video as you do this. Right, great. So here are the answers that you should have. Answers on a postcard, please, if you want to query any of them. I am very unlikely to make mistakes. If there's a mistake, probably someone else has done it. Different maths teacher. Lovely. So we've got all of our answers here. Fabulous. Right, we're going to have a look at some non-standard examples here when they're in a context. So Amir and Rosie are rounding pi to one decimal place. They've used pi a lot before, early on in the year, before Easter. So we know that's what pi is roughly, but it's a never-ending decimal. Rosie says 14,159, so she's looking at this element, is much bigger than 5. So the answer is 3.2. Whereas Amir says pi is less than halfway between 3.1 and 3.2, so the answer is 3.1. Just pause the video and think about who you agree with and why. Good, so I would agree with Amir, because pi to 2 decimal places, if we look here, is 3.41. Okay, when rounding to 1 decimal place, so when you round 3.14 to 1 decimal place, you get 3.1, which is of course closer, means it's closer to 3.1 than 3.2. Rosie's just gone in here and ignored the 3.0 and said, right, 14,000 is closer to 5, so I'll round up, but we know that's not quite how it works. Right, next one. Draw each number line in your exercise book and mark the given decimal number in approximately the correct place on each. So draw those 2 number lines, then mark the position of 6.847 on these 2 number lines. Do it in pencil, please, and pause the video as you do this. Right, good. So the first one, 6.847 rounded to 1 decimal place is 6.8, and therefore it should be closer to 6.8 than 6.9, so you'd have it roughly here. Next one, 6.847 rounded to 2 decimal places is 6.85, so it should be closer to 6.85 than 6.84, so roughly there. Lovely. Right, we'll have a go at some true or false. So 21.5 rounded to the nearest whole integer is 22. Well, that's true. 15.99 rounded to 1 decimal place is 15.1. Well, that's false, because we know that first 9 might change, and it's this 9 in charge, and it actually rounds it up to a 10, which we know can't happen, so you should have 16.0. Right, when identifying 18.451 on a number line, you would highlight it as being closer to 18.4 than 18.5. That's false, because if you did it to 1 decimal place, that 5 would round it up, so it'd be marginally close to 18.5. 0.725 lies exactly halfway between 0.72 and 0.73. That's true. Right, James has correctly ordered these numbers smallest to largest. Has he? Have a quick look, pause the video and see if you can work out if he has, and if he hasn't, what mistake has he made? Right, good. We should know it's false, because we should actually know that this value here goes in the middle there. Lovely. And if you were to use rounding to 1 decimal place to estimate the answer to 14.57 plus 21.63, you would get an answer of 36.2. Just pause the video and work it out. Right, brilliant. It's true, because 14.57 will become 14.6, and 21.63 will become 21.6, and then you can do your calculation. So 6 plus 6 is 12. 1 plus 4 plus 1 is 6, and 1 plus 2 is 3. Lovely. Have a go at these is this correct questions. See if you can work them out, take some time over them, and then once you've done that, you can have a go at the worksheet in your workbook. So you might want to have a go at these first, and then do the worksheet in your workbook, and then complete the relevant Hegarty math task or tasks. Very well done, Year 8.